The dissemination of cutting-edge technologies within the sector is one of the key objectives of the STARR Project. This is achieved in close collaboration with the main stakeholders. The promoted technologies encompass the application of Soil Quality Index or SQI method, the promotion of CO3 grass, and the integration of a Global Positioning System or GPS. When a tea plantation has reached its marginal productivity level, it has to be replanted to increase productivity. In such cases, it needs to undergo a soil rehabilitation process after uprooting of the old tea bushes. Traditionally recommended grass species, Mana or Gautamala, are cultivated and regularly lopped off, adding to the biomass of the same land for soil rehabilitation. This process can take 18 months or more. Many smallholders are reluctant to opt for the tea replanting process as they fear losing their income source during this period. STARR Project, with the technical collaboration of the Tea Research Institute or TRI and the Tea Smallholder Development Authority or TSHDA, jointly promoted CO3 grass as an alternative technology to reduce the soil rehabilitation period down to 12 months. The STARR Project provided CO3 planting materials, technical knowledge and supportive guidance for project-assisted tea smallholders with the support of TRI and TSHDA. Initially, the CO3 promotion focused on the low country wet zone areas across project-enrolled tea smallholders in Galle and Mathura districts. Recognizing the potential, the project extended the CO3 promotion over some areas in the Badulla and Ratnapura districts, which are characterized by a single tea replanting season. It was further introduced to Kandy and Nuwara districts appropriately. Under the STARR Project, tea replanting has been completed in 287 hectares of land belonging to 1,387 smallholders by June 2023 utilizing this method. This technology forwards the smallholders to start early harvesting from the new cultivation 6 months ahead of tea plantations replanted with Mana.
මට හම්බුණා CO3 ඇත්තටම අනිත් මාන වර්ග වලට වැඩිය ඒකේ වැඩි ප්‍රතිලාභයක් අපිට ලබා ගන්න පුළුවන් වැඩි පසට වැඩි පෝර ප්‍රමාණයක් ලබා ගන්න පුළුවන් ඒ වගේම අනිත් මාන වර්ග වලට වැඩිය අපිට අවුරුද්දක් වගේ කාලයක් තමයි පොළවට පෝර වෙන්න කපලා දාලා තියා ගන්න පුළුවන් ඊට පස්සේ අපි තේ ඉන්දනවා දැන් මම තේ ඉන්දලා තියෙන්නේ.
The project supported the TRI to establish 2 CO3 nurseries in Galle and Ratnapura to increase the availability of CO3 cuttings and meet the demand. Based on the results achieved through STARR Project's interventions, this technology supports the achievement of the annual national tea replanting targets. It has become evident that tea smallholders can significantly enhance the economic efficiency of their tea replanting practices by adopting a more practical approach. Tea, as a perennial crop, needs to undergo a soil rehabilitation process for more than 18 months prior to replanting. As per the general guidelines, the tea replanting is done by adopting an 18-month soil rehabilitation process employing Mana or Gautamala grasses. However, the protracted duration of soil rehabilitation, coupled with the lack of income from land and limited technical knowledge among tea growers, has resulted in minimal adoption of this practice by the smallholders. Bridging this gap, the Tea Research Institute devised a method for evaluating soil quality, enabling the recommendation of direct tea planting, avoiding the soil rehabilitation process. This is known as the Soil Quality Index or SQI method, which assesses the soil suitability of tea lands for the direct planting of new tea. The SQI method serves as a tool to determine whether such land plots can be used for direct planting or otherwise undergo a CO3 or Mana-based soil rehabilitation process. Recognizing the significance of the SQI technology, The STARR project promoted this technically qualified method, integrating it into the tea smallholder sector. The project actively utilized the SQI method to identify fertile lands suitable for direct tea replanting, thus avoiding the lengthy soil rehabilitation process. The STARR project has supported the replanting of 91 hectares of tea lands under the SQI method, encompassing 275 smallholders.
පසේ පරීක්ෂණයෙන් පස්සේ එයාලට පසේ සාරවත්භාවය පිළිබඳ සෑහීමකට පත් වෙන්න පුළුවන් නම් අපට කෙලින්ම ශාස්ත්‍රීය පළ සිටුවන අවස්ථාව දෙන්න තිබුණා. ඉතින් එතෙන්දී පරීක්ෂණය සඳහා ලොකු වියදමක් යනවා. ඒ වියදම් අපි මේ ස්ටාර් ව්‍යාපෘතිය මගින් දරලා මිනිස්සුන්ට ඒ ක්‍රමය පිළිබඳව අවබෝධයක් දුන්නා. ඒකෙදී මේ පිළිබඳව ලොකු ප්‍රචාරයක් ලැබුණා. මිනිස්සු මේකට පෙළඹුණා. ඒක නිසා අපට ඒක නව අවස්ථාවක් විදියට ස්ටාර් ව්‍යාපෘතිය මගින් අපේ කුඩා තෙවතු හිමියන්ට ලැබුණ අවස්ථාවක් කියලා පෙන්වන්න පුළුවන්.
In addition, the project assisted the TRI in upgrading the 2 laboratories in the Ratnapura and Galle research stations by providing essential equipment, tools and chemicals with necessary infrastructure modifications at a cost of 16.5 million rupees. The project further invested 11.9 million rupees for operational field activities and human resources to carry out soil testing under the SQI method for issuance of certificates to smallholders who led the direct planting of tea. This method has demonstrated its effectiveness as a valuable new technology for enhancing tea cultivation practices. The STARR project highlights the possibility of developing a policy for SQI-based general practices in tea replanting. STARR project collaborated with stakeholders to introduce the Global Positioning System or GPS to expedite land measuring practices in tea and rubber sectors by replacing the time-consuming manual land measuring method.
GPS තාක්ෂණය අපිට හම්බ වෙන්න කලින් අපි ඉඩම් මනින්න පාවිච්චි කරේ සාමාන්‍ය මිනුම්පටි. සාමාන්‍ය මිනුම්පටි පාවිච්චියෙන් අපි ඉඩම් මනිනකොට සෑහෙන කාලයක් අපිට ගත වුණා එක ඉඩම මනින් කටයුතු කරන සාමාන්‍යයෙන් දවසකට ඉඩම් 4ක් හෝ 5ක් ආදී අතර ප්‍රමාණයක් තමයි මිනුම්පටියකින් මිනුම් කටයුතු සාර්ථකව සිදු කරගන්න පුළුවන්කම ලැබෙන්නේ. නමුත් GPS තාක්ෂණය අපේ අතට ආවට පස්සේ අපිට තනි දවසකට ඉඩම් 10ක් 15ක් අතර ප්‍රමාණයක් මිනුම් කටයුතු ඉතාම සාර්ථකව කරගෙන යන අවස්ථාව ලැබිලා තියෙනවා. ඒ විතරනේ ඒ වගේ නිමෙරිතාවයක් ඉතාම නිවැරදිව අපිට ලබා ගැනීමේ හැකියාව උදා වෙලා තියෙනවා.
The project provided 107 GPS devices among 107 field officers in the sector, also disseminating necessary technical knowledge through a series of training programs in the project-supported districts. The project supported the measurement of nearly 3,125 hectares of tea land and 1,704 hectares of rubber land by using GPS technology. This service has been extended to measure lands of non-project beneficiaries in project-supported districts. It was also implemented in non-project districts like Galle and Kalutara.